Hello everyone, welcome to our midterm examination review for DDComm. And for this video presentation, we'll just have a short overview. Let's just recall the different topics that we have here in DDComm. Well, actually, the reading materials that we have here is almost complete. I have already included the explanation. All you have to do is to read those details and to do the different tasks for you to maintain the knowledge that you have read. So today, as a preparation for your examination, let's try to revisit the modules. So in your midterms, we have module 1, network fundamentals, module 2, signals, and the last module, module 3, bandwidth and transmission modes. So let's take a look at the first one, which is the easiest one because this is just a short overview of what is computer networks. Okay, so in here you have learned, okay, what is data and information. So we'll go back to that idea again. We have the data communication, data representation, the data flow, computer networks, and also the history. Okay, and we have here the standards in networking. These are the organizations that comprises the rules when it comes to designing your computer equipments or electronics. Okay, so that to support the data communication between computers. So we have here again data and information. You already know the difference between data and information. The data is something that we know, while the information is um, the process data. Okay, this is something that we could conclude. Okay, and then we have the data communication, of course, the transfer of data. So it's very complex when we talk about data communication because the idea of trying to transmit signals, okay, in especially in a long distance setup, so we have to consider a lot of things. Okay, so that's why we have to take note the delivery, the accuracy, the timeless, and then the jitter. So those are the characteristics of data communication. Okay, components. I guess this is clear to you. Of course, for to transmit data, it's the same as transmitting a message, the manual transmitting of message to our to another person. Okay, it's just like speaking. So we have a sender, we have the transmission media or the way or um, the process on how we transmit, how we would like to let the other party know the message. Okay, so that's it. That's the components. And then data representation, you know this one. And we have also the data flow. We have the simplex, half duplex, and the full duplex. Okay, so this is also a very critical part of data communication, wherein you should design, okay, your um, digital signal processing in which it can be supported with this different type of data flow. Okay, and then we have the computer networks. We'll be having this one more on your net acad one. I net acad. That's net. I forgot the name of the subject. Your next subject after this one, but that is the CCNA one for Cisco, under Cisco, I mean. Okay, then we also have LAN one. I think you have heard about this already, about the different types of communication. Actually, it differs on the number of nodes that are involved in the network. Okay? Early history, telecommunication development, and then computer connection, wireless. So I just want you to read this one so you have an idea how we evolved data communication. And then we also have the protocols, which is also um, the heart of your CCNA 1 after this subject. Okay, so these are the syntax, these are the semantics, the timings, right? These are the rules that governs data communication. Of course, we have to set a single rule for any data communication. Any devices, dapat meron tayong iisang rules or iisang um, guided rules, okay, na pina-follow natin, especially in designing our electronics. Okay, and then we have the standards networking, the same. It's the rules that we follow. So we have de facto and then de jure, okay? De jure. So these are the regulation, law, okay, set by the law and regulation. We have documents on this. And then we have de facto, these are the standards traditionally used. Okay, so in data communication, we also have this. And then, of course, these are, take note of this, organization. So they are the one who maintains the regularity of data communication. Okay, like for example, the Bluetooth, um, the not the Bluetooth. We are more familiar with the USB. Okay, so as you can see, every electronic devices like laptop, okay, computer, even if that is a laptop, even if that is a computer, as you can see, the ports are the same. The design of the ports are the same. The symbols are the same, right? Even if they have different manufacturer, different company, but they follow the same design, the same functionality, okay? Because they follow this organization. Okay, if we do not have this one, just imagine a device talking to the same kind of device. So our data communication will be limited. Okay, that's why we have the following, so that even if we have a lot of devices, we can still provide or we can still process data communication. Okay, so actually that's it. This is very simple. The module 1 is very simple, just an introduction and then of course the networking standards. Okay, so actually your goal here is just to understand what are these organizations are trying to maintain. What are the goals of this? So International Telecommunication Union, okay, under United Nations, and then we have IEEE, okay, Technical Professional Organization, okay. So I hope you watch those um, video clips because it explains the job or the goals of this network standards or network organization. Okay, so that's the networking fundamentals. We already done with the quiz 1 of this. So no problem. Let's go now to the signals. So signals is actually the measurement. This is the unit of the data that we would like to to transfer or to process. I mean, okay. So signals. Okay, so types of signals, we have analog data and then the digital data, types of data. We have analog data, digital data. Therefore, when it comes to signal, we have analog signal and digital signal. So as you can see, these are the difference between them. Okay, so we have a lot of information that would differ the analog and then the digital. But as you can see, guys, if you will just focus on the waveform of analog and digital, we would see the difference Okay, so digital is just there's a specific value for each time. Okay, while the analog it varies in different time, different period. Okay, and we usually analog is usually represents the real world information like the sound. As you can see, the sound changes every time. Okay, high pitch, low pitch, and then there is some levels of the pitch or the volume. While the signal, the digital signal, these are one or zeros only. Okay, so here we have analog signal. We have different characteristics of analog signal. We have the peak amplitude. Okay, low peak. I guess you've taken this one. I'm not sure what electronics. I guess electro. So this is just a review to you. So peak amplitude, we have the frequency. Okay, these are the terms that you will be encountering later on. So we have also here the computation on how to get the frequency, the period, right? We have also the phase, right? So those are different characteristics of an analog signal. Okay, we have also a composite signal. These are the combination of signals, like this one. Okay, we combine them. Okay, and then we will come up with the composite signal. So why do we combine them? Okay, because we have to process the signal in order for us to transmit. Okay, so this one, like for example, this is the original signal, and then I have another signal. I have to combine them in order for them to be to at least form into a digital. Okay, because why do we need to convert it to digital? Okay, actually this is under your DSP later on. We convert signal analog to digital for us to first transmit the data. Okay, because technically our channel, okay, our channel, yung light, electronics, or the different ways on how to transmit data uses an instrument or uses a stuff that is on digital. Okay, so we want to transmit the data into digital so that we can transmit the data. Okay, and aside from that, in order for your computer to read and then to output data, because computers are digitals, right? While while the real world data is analog. So we have to do something, and this is one. We have to create composite signal, but the composite signal is what we call the combination of those combined signals. So we have here bandwidth of the signals. I please watch this also to have a good idea of what is a bandwidth of the signals. So another one, we have digital signals. So um, it's very obvious, okay, because in digital signal there is only zeros or one. Okay, so we'll have this one in your DSP, more on this on your DSP, especially the computations. Okay, the actual changes are the actual transformation of signals. Right, and then here we have transmission of digital signal. We have the baseband transmission and the broadband transmission. So in here, signal is transmitted without any changes. Okay, because it's already a digital, so no changes at all. But for broadband transmission, okay, we have the bandpass channel, and the digital signal cannot be transmitted directly through it. Okay, because we have a band pass channel. If you're using a band pass channel, channel is actually parang just imagine that is the wire, okay, that would transmit the data. So if we're using a bandpass channel, we cannot transmit the data. Therefore, we have to use modulation. So we change it. So that is what we call the broadband transmission. So we change signal to analog before transmitting it, right? So this time we will change it to another, from digital to analog, okay? So that's the difference, baseband and then broadband. This one modulation, this one without any changes. And then kindly just read the other information about them. Okay, so that's the signal, guys. So we have this module is more on analog and digital signal. So the difference between analog and digital signal. So we have different forms of signals. Okay, and then we have also the modulation. Oops, the modulation. Okay, so I've mentioned that from the previous one. We have modulation. It is used to change. Okay, we change the signals. It can either be analog to digital or digital to analog. Well, we do modulation simply because we want to transmit data. Right? So why do we need to, to modify the signal? Because we have different characteristics of telecommunication channels. We have different characteristics of the devices. Okay, so we have to make sure that both devices, both the channel and then the devices can understand the signal, can transmit it without any loss. Of course, we cannot avoid loss when it comes to signal transmission. Okay, but our goal as professional in data communication, we have to design, okay, a circuit that would minimize these noises, minimize the loss, okay, and maximize the transmission, okay, the accuracy of the transmission and also the speed of transmission. Okay, so this one modulation, I have a lot of information here, so please kindly go over with this. Okay, so try to understand what is modulation. So this one, okay, digital signal, ISP modem, and then we have the analog signal. This is the telephone, for example. Okay, we transmit audio. Audio is an analog. So how do we do that? When our ISP or our server, our PC is digital. So we do modulation. Okay, so modulation process. Okay, modulation process involves carrier wave. We add carrier wave to the original signal in order to transform the signal into something that can be transmitted. Okay, so yeah. The process of modulation will be discussed in your DSP in more details. But of course, you should know what is amplitude, frequency, wavelength, and phase before you go there. Okay, so this one, modulation method. We have analog modulation, digital modulation, pulse modulation, spread spectrum. So we have different single carrier, multi-carrier, carrier modulation. Okay, so carrier wave, this one, oh, just try to imagine from analog modulation, analog to digital. So we add, this is the modulating wave, okay, and then we add this to in order for us to have this wave. Okay, so amplitude modulation siya. Okay, so we have frequency also the same. Frequency, amplitude, just try to read the difference between this. Okay, when do we use this? Actually, this is your activity, so I don't need to repeat this. Okay, we have also digital modulation, signal, single carrier. Then we have the amplitude shift key. Okay, so from digital. okay, to analog. So there are computation that happens during this modulation. Okay, so try to understand the difference between this type of modulation. We also have the pulse modulation, which signal is transmitted into form of pulses. Okay, so instead of the carrier, we'll be using pulse modulation. Okay, pulse naman. Pulse modulation classified into two major types. We have analog indicates sample amplitude, and then digital indicates sample amplitude at the nearest predetermined level. So the process is very different, okay, but the output is the same, and the goals or the your um your objective is the same. Okay, so I think you already know this because I let you do this, just the simple example. Okay, so go over with your assignment again and then look for the answers for this one, because um, if you understand, if you have the application for this modulation, you'll be able to understand what is the difference between them. Okay, and lastly, by the way, oops, sorry, I forgot to change this, but you'll be having a quiz later. We will start, we will start at 1:30. So 1:30 to 2:30, quiz 2.1. Okay, and then later on, 2:30 to 3:30, I'll give you your quiz point at 3.1. Okay, so last, we go now to the bandwidth. So we all know now why we need to transmit data. And then on this module, what exactly happens during the transmission of data? What data, what what form would our data be during the transmission? We have signal, and then the process of the transmission, the process for preparing the data for transmission, we have the modulation. So now the other thing that affects the transmission would be the bandwidth and then the transmission mode. How do we transmit this time? So here in bandwidth, okay, so in bandwidth, and so what is a bandwidth? Okay, so bandwidth is actually the volume of data received in specific time period. This is not the speed, right? Because the speed is how fast the data is received, but the bandwidth is how many data, okay? How much data did we receive in a specific period of time? Like for example, in 1 minute, okay, this transmission mode transmits 1 gig. Okay, the same minute this transmission mode transferred, or in 30 seconds transferred siya ng 1 gig din. So if we're going to compute for 1 minute, 1 minute, so in the second transmission, we'll be able to transmit 2 gig. So that's better. Okay, so that's why it is more likely to be connected to speed, but they're not the same. This is the data, the volume of data, but when it comes to bandwidth. Latency is the ping rate, the total amount of time spent in transmitting the data. Okay, so that's the latency, the total amount of time from from the sender to receiver. And then we have the last one, the throughput. Okay, so what is the throughput? How much information actually gets delivered? So more on accuracy. Okay, so that's the difference. How fast? Okay, and then the exact time it spent in transmitting the data, and then how many how accurate the data is transmitted. So bandwidth of an analog signal in terms of frequency. Okay, it defines as the rate, the change as the range of frequencies that the composite analog signal carries. Okay, so I guess this is very simple. Kilohertz, right? That is the bandwidth for analog, and then letter C, bandwidth for digital, refers to the maximum bit rate of the signal. Okay, bit rate, or so bits per second. While this one in analog, kilohertz. This one bits in second in digital signal. Okay, because we transfer bits here. This one we transfer in a form of frequency. Okay, and then bandwidth of the channel, of course, the channel is the medium through which the signal carrying information will be passed. So even if you have the speed will be affected by the bandwidth of the channel, because it will tell you how many data it can carry. So actually, this is what the service of your ISP is serving you. The PLDT, the Converge, the Globe, okay? So they are giving you the bandwidth of the channel. So how many or how much space did your ISP um, is given to you, okay? So something like that, so that you would know if how much information you can transmit, something like that. So the speed will be affected kasi kung mababa yung bandwidth of the channel mo, syempre unti lang yung makakadaan na information doon. Pag unti lang, matagal yung information. So that is the matagal yung transmission, I mean. So that is the bandwidth of the channel. Okay? So actually, this is the data rate. I just showed you this, but you don't know, you don't need to really memorize this in details unless you will be working on the network. Although even in your working with the network, at least you know Nyquist bitrate, okay, Shannon capacity also. So we have different computation in order for us to check how many available information that can carry given a bandwidth of the channel, given the bandwidth, yeah, given the bandwidth of the channel. Okay, so I think that's it. That's the last one in our midterm exam, my midterm period. So again, modules, let's go back here. So network fundamentals, signals, and bandwidth and transmission mode. So for today, we will be having just your quiz 2.1, and then quiz 3.1, and the next meeting will be having your final exam. Okay, your final exam will be in Kahoot. Okay, I don't know if I have let you try Kahoot. Okay, but let me check. I'll give you I'll give update regarding your midterm exam, because I use Kahoot when the number of students are lesser. But this time we have at least 30, since Kahoot has a limitation with the number of participants. So I will try to look for another one. Okay, let's just see. Let's see how is that. Okay, so please wait for my update. But for today, I want you to take this one, quiz 2.1 today, later at 3:30. 2:30. Sorry, 1:30 to 2:30. And then quiz 3.1 to 3:30 to 2:30 to 3:30. Okay? So we will start 1:30 to and end to 3:30. Okay, that's it, guys. Thank you. So if you have questions, kindly just message me. Okay? Thank you. Have a nice day.